Sir, good afternoon.
Professor, how are you?
Fine, fine. So nice to meet you, Miss. I saw it from the net only, your profile,
Okay.
and I gone through your profile. You have done
Am
so
I
many things.
audible?
Hello, pardon?
Am I audible, Professor?
Yes, yes, yes. You are audible. And I think the student is joining. We can start at after 2 minutes. So, so currently, sir, you are taking some NLP classes or only?
Sorry, no, I will put a platform. Actually, your voice is little breaking, so I, I don't know. There must be some problem at my side.
Some network issue. From my side is breaking. It's breaking from my side, or is it clear now?
Am I audible, Professor?
Yes, yes, you are clearly audible. Uh,
Yes, yes. Okay, okay. Now it's better.
Currently, you are vacation or
No, no. Actually, before 8 months, I joined Dhirubhai Ambani University.
yes,
So,
yes.
I mean, it's the first year, and I have a lot of work. I mean, there are so many revisions I have to do, and we also have a major project.
Okay,
I
okay.
mean,
That
the
currently going
student.
on.
Yeah,
Government
yeah.
project or which one? Yes,
No, no. I mean, there are some government also going on, and some uh, who are also working with me in major project.
okay,
So
okay.
I have to be in campus.
Okay, okay. So I am also in campus. There are no
Oh,
holiday for me.
okay.
But
Yeah.
sometimes try to visit KIT. Fine. So
Sure,
that is
sure,
in fact.
sure,
So I
sure.
think let us start the session. Let me introduce yourself. Introduce you in front of our participant. Then you can start the session.
Okay.
Okay. Okay. Just to give me 1 minute so that I can introduce. So today we have with us Dr. Sandip Mudha, who is currently working as an assistant professor at DAU, Dhirubhai Ambani University, India. So he obtained his PhD from DAIICT, which is DAU, Gandhinagar. So his research interest span NLP, IR, this information retrieval, especially on low resource language technology, text summarization, misinformation detection, hate speech analysis, and evaluation methodology by using the AI systems. Prior to joining DAU, he has completed his PDF, postdoctoral research fellow at the University of Milano Bicocca, Italy. So, contributing European research project on misinformation detection and AI evaluation. So, today's topic is that is on tax challenges in low resource Indian languages. So now, sir, thank you very much. In a short span of time, you have accepted our request and joined as a resource person. So now session is yours, sir. Thank you very much. You can share the screen and you can start the session.
Thank you, Professor Das, for. Okay, I will just share my screen.
Yes, yes, sir.
Uh, some of the students to join the. Can I share the link with them? I'm not sure if you allow one of
Which
my
one?
students. I
Yes,
mean,
yes, yes, sir. Definitely, definitely, sir.
okay, sure, sure, sure. I will just
Take,
share.
take 1 minute to share the link,
Okay, okay,
all
okay.
of them.
Sure. Thank you.
I've already given one. Before that, I
Yeah,
have given one mail also
yeah,
to share
sure,
all
sure.
the students.
Yeah, yeah.
Link
I
and
shared with them, but I don't know now. They are okay. I'm not sure.
yes, yes, yes. They can join, sir. Faculties also you can share, no problem. Anyone you can share.
Can you see my screen?
Yes, sir. So make it
Okay.
full screen and start.
Oh, yeah, yeah. Okay. So basically, 1 minute. I will discuss some of the tasks in low in the era of LLM. So So basically, I'm working in a problem. Basically, NLP problems are, three types: sequence generation, classification, and sequence label. So we are contributing. I mean, in our lab, different students are working on three broad type of problem. So translations, machine translations, summarizations, these are the sequence generation tasks. So in this presentation, I'm going to present these first three tasks in detail. That how do we create the benchmark for the Indian language for the summarization task. Then we also formulated the data set. I mean, synthetic misinformation generations and detections problem. And the third task is how do we, generate the prompt. It's basically reverse engineering uh, from from a given misinformation. Can we recover the prompt which was used to generate the misinformation? Because right now, people use LLMs, some vulnerability and use, they adversely attack on LLM and try to generate the, misinformation. So these are the three tasks I primarily discuss. We also work on a sequence classification. So I will discuss briefly type permit and the sequence labeling tasks. So these are the 6-7 tasks where our labs basically works. So let's start with the why this low resource language. So basically, English, Chinese, Spanish dominate the current NLP landscape because a lot of LLMs, transformer, fine tune on Chinese or Spanish are available. For Indian language, we have to rely on a translation approaches. So there are some transformers are there, some, but still we are not at par with the resource reach. So basically, we establish a IL some Indian language summarization IL some forum at FIRE conference. So basically, we want to create a benchmark data set for the summarization. Was our primary goal. Um, so this is a FIRE conference. Now this is the 18th FIRE, which works with the Indian languages. Uh, this year it will be the 18th FIRE and it will be held at Kolkata during 17 to 20 December, where you will find a lot of tasks. You visit the website and generally we run the evaluation forum so that participants submit their system. We formulate the problem. There are many collaborators. We run the task evaluation forum. We generate the benchmark data, and you know so we see how systems perform against those benchmark. So basically, as this research current NLP progress skewed towards resource-rich language, but India 1.4 billion speaker. So our objective is to be a South Asian counterpart of the TREC. So TREC is a text retrieval conference held at the United States. Similarly, there is a CLAY in Europe, and FIRE is one, their alternative for the Indian language, because each continent they are running forum for their language. So we think that in 2008, Professor Mandar Mitra, under the leadership of Professor Mandar Mitra, we started the FIRE. And I am associated with FIRE from 2000. Basically, I will discuss the various summarization tasks. So let's to understand the formal problem statement. So summarize is basically, I don't know if the screen is okay. Basically, the summarization task is lots of document and we need to create the summary in a maximum 75 words. And the summary's nature can be extractive or abstractive. So, we focus in formulated the problem in 2022, 2022, and we started two Indian language, Hindi and Gujarati. So basically, summarization, we need a gold data. So human summary. So basically, the automatic summary must be evaluated against the human summary. So that was a challenge because we have to recruit a lot of people for create the human generated summary. So to avoid such large cost, we think that let us use newspaper article, and the title of the newspaper is basically headline. Let us keep it as a summary, and the detail is a document. So this was our idea, and we started to create the IELTS data set. So now let us focus on extractive and abstractive summary. What is the basic difference between extractive and abstractive summary? So this is, basically just example. Now, first sentence is in Gujarati and second is it in Hindi. Now, sometimes, we face code mix challenge. So, the Gujarati Hindi article contains some of the English word. If you see the second statement, LIC IPO. Now, these are the abbreviation of English, some of the name entity, LIC. They are written in English. Similarly, India versus South Africa, this is English. So this is a problem. Code mix is the biggest problem, while doing the summarization. So this is the headline generation part. Now let's try to understand text summarization. So basic idea is to create the shorter version of the document. Two technique, extractive and abstractive. Now let us focus on this two part. So extractive summarization, basically we extract the main sentences from the document. What are the highlight of the document? So we analyze the document, we give score each sentence using some of the scoring method. We'll discuss in the later slides. And we extract those sentences and arrange into summary. So basically, out of document, we select the important part of the document. So if you see graphically, let's say this is a document. Now there is a blue part and orange part. So orange part is the selected summary. So we are not playing with any. We are not generating any new sentences, but we are selecting the sentences from the existing document. So that's the extractive summarization. Now comes, so this is one example of extractive summarization. Here is a Chandrayaan, some of the story. So what we do, extractive summarization will do, it will select first two sentences, and this sentences is basically summary contain the exact sentences copied from the source document. So first two sentences are copied, and that is extractive summarization. Now let's move on to the abstractive part. So abstractive summarization generates summary by understanding the document like the LLM does. They understand the semantic representation, build the semantic representation, and identify concept and relationship, and then generate the summary like we do. We read the article, and then someone will ask what is the article is about. Then we frame the sentences and tell the story. So that's basically abstractive summarization. So something like this semantic representation of the concept and the relationship, if you can see the graph. So basically, the abstractive summarization is we are not copying anything from the text source document, but we generate the sentences using the concept from the source and relationship between the source document. So here is one example of the abstractive summarization. So same example. So now here the subject Chandrayaan 3 mark. So it start with the Chandrayaan 3. So you will not observe similar sequence in the original text. So new wording and combine information from the multiple sentences. So that's the abstractive summarization. So with this, there are some pros and cons. Abstractives are more concise and fluent summary. So that's why we use LLM, because they do the abstractive summarization, more human-like, and can merge the different part of document. That's are the pro. But sometimes LLM hallucinate. So it may produce a factual error. Now, before the LLM, there are many techniques, but we need a large label data set for the abstractive summarization. Now, right now, people use, transformer and LLMs for the summarization, but initial classical approaches are, to score the sentence, we use TF-IDF. There is a text rank, lex rank for the extractive summarization. For abstractive, there is a rule-based method, information extraction method. Now, I'm not going to into detail. Otherwise, there will be a different talk. So these are the classical approach. But nowadays, people use transformer. I mean, I will discuss all the teams approaches which they submitted the run in our evaluation forum. Okay, so I will just briefly discuss the text rank. So this is a extractive summarization method. So let's say there are 4 sentences, S1, S2, S3, S4. Now S4 is completely different. Football is the most popular sports, and remaining 3 are AI and healthcare domain. So all the sentences are the node. Ages are the similarity between sentences, and weight is the similarity score. So then we apply page rank to identify the most important sentence. So that's how the extractive summarization work. Text rank, very old method, before the LLM era. Now I will let you know the data set we prepared. In 2022, we prepared the data set in 3 languages: Hindi, Gujarati, and Indian English. Now the Indian English is significantly different in terms of dialect from than the standard US or British English. So we denote them as a Indian English. So there are around 10,000 plus articles in all the languages. We thought article is around 400, so that we can generate the meaningful summary. And similarly, the average word summary is a 37 words per summary. So basically, we use article headline for the gold standard or human and label them as a human generated summary, and the article is text. We gave that to the participants, and participants needs to generate the automatic summary, and then we compare the automatic summary with the human generated, and there are some methods we will discuss how to evaluate the summary of the two, basically, I mean human and automatic or machine generated summary. So this is the statistics of the data sets. So data sets are sampled from news portal. So there is a Gujarati news portal, Hindi, Indian English, etc. Now, if you see, I don't know whether you people are comfortable with Hindi, but now we do not work in Odia. So Odia is still, I mean, we never work, but we want to work with the Odia language. So this is a Hindi sentence. I don't know whether you can read it. So this is the original summary. Himachal Pradesh flash food की फ्लैश फ्लड की वजह से नाले में अचानक पानी बढ़ा, something like that. So this is some original summary. Now we gave the article to the systems, and different participant teams have generated this summary. So they all have a different models for the summarization. So these are the 3 different summary. Now we have to evaluate their summary with our original summary. So there we can use rug score. We'll say in the next slide. There are other like Meteor, symmetric 2 is there. but we use rug as a keyword. I mean, next slide, I will see it. So the approaches basically are, MT5, MBART, INDIC-BART. In 2022, I'm talking. So I will tell you the story from 2025, how the different people use, I mean, different approaches are based on different, AI models. So the MT5, MBART, INDIC-BART are the most popular choices for abstractive. Some people use k-means clustering, because if you cluster the sentence, then pick each sentence from each clusters and then club it. This is also one way to create the extractive summarization. Now, some people use, translated the Gujarati and Hindi article into again back English, and then they generated the summary. So these are the, some approaches for the summarization. And here are the result. So, when we started the Indian language summarization forum, these are the top 5 teams. They submitted their run. Now, if you see rug 1, rug 2, rug 3, basically F1 score, rug is, they are the, basically number of, rug 1 means how many unigrams are matching with the reference summary. Rug 2 means bigram, trigram, rug 3, and so on. So if you see on English, we are getting 0.558. So more than half unigrams are matching. Rug 2, rug 3, so it's a 40% around. And rug 4.41418. So these are the various team, and the F1 score is range around 0.479 to 0.558. So similarly, for Hindi, the rug score is good, but for Gujarati, we are getting very bad rug score that start from 0.6261 to 0.124. So, this is the first, I mean, we are the first people who, offered a summarization task in a Gujarati language. So we think that there is a scope for the improvement. We need resources, benchmark for the Gujarati, for the Indian, low resource languages. So that's how, this is the first indication, the lower rug F1 score. Now, if you compare with the Hindi, it is, less than half. So this was, our observation, and then we started that we should work for our languages for next 2 to 3 years. So each year we release the data set, and then we gave to the research community, and research community use the innovative approach for the, solving the problem. We evaluate them, and then, these are the results. Now let's go to the RUG score. Basically, what is it's a recall-oriented understudy for existing evaluation. It's a widely metric used in a machine translation as well as summarization part. So here, basically, we measure the overlap between a generated summary and reference, means human written summary. So if I can take the 1 minute. So here, let's try to understand rug 1. Rug 2 will measure 2 consecutive words. So let's say summary contain this 6 word, the cat sat on the mat. And let's say generated summary have a like the cat is slept on mat. Instead of sat, it's a slept. So basically 5 tokens are matching. 5 words are matching. Unigram, I'm talking about unigram. So 5 out of 6 words are matching. So now what we do is we calculate recall and unigram and precision. So in the next slide, it's a very simple equation. Number of matching unigram divided by total of unigram in reference summary. So in this case, there are 5 unigrams are matching, and total unigram is 6. So we are getting recall is equal to 0.833. Similarly, precision. And now here match n-gram divided by generated n-gram. So in this case, the denominator is changed. it is also a 6. So we are having 0.833, and that's how, we get 0.833 F1 score, which is a harmonic mean of precision and recall. So if you refer, so this is how we calculate F1s for rug 1. Now for rug 2, we consider diagram. For rug 3, we consider trigram, and so on. So that's how our first result, we started with Hindi, Gujarati, and um, uh, Gujarati and English. So this is a rug one F1. Okay. Oh, 1 minute. So, so after, offering this task, what we think that what our objective was to create benchmark data set for the text summarization for the Indian language, specifically for Indian Hindi, Gujarati, along with the Indian English. So we observed that, people use around MT5, MBART or Indic BART. Traditional approach is also used like text rank, and RUG F1 score metrics consistently in English and Hindi, but in Gujarati performance was very poor. So we may not say that Hindi is a low resource, but the Gujarati is definitely low resource language, because we don't have a proper transformer, which can be used over here. So that was the one reasons. Similarly, in 2023, we added Bangla. So as you know, there are 250 plus million speakers worldwide. And we also, the complexity increase with unique script and morphological structure. So if we go to the IELTS, then we introduce the BERT score. So there is a significant difference between BERT, BERT and RUG. They have a correlation. But if you see, the BERT is 0.82 and RUG is 0.56. Now we will see how how the BERT score is calculated. So this was in a RUG for the Hindi is 0.56, so it's the same range of 0.6, 0.56. But for Gujarati, it's again 0.174. So we did not get any significant improvement for Gujarati also. For even Bengali, we get RUG 0.12. So it's basically keyword matching. If you consider the BERT score 0.74, which is significantly, less than the 0.82, even 0.70 for Bengali, and for English, we are getting good and BERT score. So let's try to understand what is BERT score basically. So let's say the boy purchased a bicycle and the child bought a new bike. Now, semantically, the sentence are similar. Now, the bike is basically, here we say bike means some motorcycle, but generally the meaning of the bike is basically a bicycle. So here, if we consider match the two tokens, now out of there are 7 reference summary contains 7 token, generated summary contain 6 token, but still the boy, child, purchase, bought, bicycle, bike, these are the semantically similar words. Now RUG will not consider this, so RUG may not be the appropriate metric, so we might get 0.5 RUG score. Now how BERT will do, let us try to understand. So as the convert each token to the contextual embedding using BERT transformer, and we compute the similarity between tokens. So of course, BERT and using BERT, boy and child have a very quite similarity. Then compute the cosine similarity between candidates and reference text, find the best matching token for each word, and then aggregate into precision and recall. So boy is equal to child. They are semantically similar. Purchase, boat, bicycle, bike. So the bird score will be high and rug score may be relatively low. So here is equation. So basically we calculate the similarity between C and R and we add them using candidate token and reference token divided by the number of candidate token. And then, similarly, we compute the recall and the F1 score. So in our case, if you see bird score is much higher, 0.82, while rug is 0.56, 0.47. So the summary, basically the semantic uh, similarity between generated summary and reference summary is quite high compared to the keyword base or phrase based similarity. So now into 2024, we expanded to the Kannada, Tamil, Telugu. So all the majority language of the Indian subcontinent. And we, provided the training data, validation data to the community. So this is our IELTS 22024 data set. So Gujarat, and we know Hindi, so we have a lot of training set. But for Bengal, Tamil, we have a limited training set. So basically, the approach is again the BART, Indic BART, BART for English, Indic BART for Hindi, and MT5 for Gujarati, Telugu. So people use these are the transformer for these languages. So top team approach, someone use MT5 pre-trained model for all languages. The third approach is singular value decomposition based summarization, then LDA and text rank. The other transformer are Excel sum, MT5 and multi-indic. So these are the top approaches for the summarization part. Now, if you see the result on Bengali dataset, again, RUG is 0.24, but the F1 score, BERT F1 score is around 0.73. So so there is ranking are preserved. So there is a correlation between RUG and BERT score because the top 5 team in the Bengali dataset is same as top 5 team in BERT score. So team remains same, ranking remains same. Only the score is changing. So there is a correlation between BERT score and RUG, but still 0.73, is we can do better for this Bengali. Similarly, for Telugu, we achieve 0.75, so the range remains same. Then for Tamil, similar range, but score is 0.73 F1. And RUG is around in the range of 0.2 to 0.3. Similarly, for Kannada, same 0.07 and RUG is 0.22. So transformer generate the summary, but not if we measure with the RUG, that's the very low, but still they preserve the semantic meaning. Similarly, this is the English data set where BERT score is 0.88. So, there is again 0.7 in the range of 0.7 BERT score for Indian languages, and for English it's a 0.87. So there is a scope for the improvement for the Indian languages. Okay. And some of our comments are basically majority participant teams use pre-trained LLM for the approach the summarization task, and they also use some non-LLM approaches, but the results are not good as with pre-trained LLMs. Okay. Now, so this is the summarization task which I summarize in first as a first task. The text task we formulated, which is based upon cross-lingual misinformation generation and detection task. So, the most of the misinformation data sets are, sampled from PolitiFact data set, or some popular misinformation or fake news data set are sampled from fact checking website like Liar, Every Take. They sampled from PolitiFact. So for our Indian language, we don't have any fact checking website. They provide us the fake news or misinformation data set. So what we did is, uh, we sampled source article in English. Then, we generated corresponding summary in Hindi and Gujarati. So first we generated summary in English, um, and then translated into Hindi and Gujarati. And then, what we did is, we asked participant that, can you say that the summary is correct or incorrect? If it is incorrect, then we define 4 kind of misinformation, like misrepresentation, inaccurate quantities, false attribution, and fabrication. So basically, this we define the notion of the 4. I will discuss in the next slides what are these 4 um, kind of misinformation. That we can generate for incorrect information. So what we did is the dataset assembly. We have an article. So summary is created from using GPT 3.5. Then we use GPT-4 to generate it incorrect summary for each class. Now I will discuss one by one. So let's say these are the 4 class. So first class misinformation is fabrication. So here is basically what we did is, let's say here is some news like uh, Trump, like Donald Trump, is some take on some kind of um, Donald Trump, some statement or some comment on Indian, like what we can say is tariff. So using some actor, we totally fabricate the story. I will give you the example in the next slide. So the fabrication with no basis in reality. So we corrupt the summary using the fabricated story. The actor remains same, but we do some fabrication. Similarly, misrepresentation. So twisting the fact or exaggerating the aspect to fit a false narrative. Similarly, false attribution. Here we change the person who speaks the statement and inaccurate quantities. So these are the 4 types of misinformation. We created the 4 class of misinformation. So let's say this is the original summary. There was a case in Gandhinagar, so some cholera incident. So like 13 this is one original summary we created from the article using GPT 3.5. So 13 individuals, including 5 children, were admitted to the health facility in Gandhinagar due to suspect cholera outbreak in the Kalol municipality. 2 cases were confirmed, prompting 2-kilometer radius outbreak area to declare cholera affected. And the state health minister communicated the situation to the union home minister, something. So this is a genuine summary. Now we try to using the prompt, we try to corrupt this summary because we want to create a misinformation data set. How LLM can identify the misinformation? That was our main objective. So the first is a fabrication. So here, what we did is, a cholera outbreak in Gandhinagar has resulted from a genetically modified strain. Now you see there is no reference to the genetically strain. Okay? So this is called as a fabrication. So we use prompt. Actually, I will show you the prompt. How do we corrupt the summary? And this has led to the 13 hospitalization. So, the outbreak is linked genetically modified strain. And escape from a lab is entirely fabricated and not supported by the original text. So this is a fabrication part of summary. The next is false attribution. So here, what we did is the World Health Organization confirmed cholera outbreak in Gandhinagar, Kalols. So here is a false attribution. Now in the original summary, this was, the cholera outbreak was, basically the state health minister, but here we changed the actor and put WHO. So if common person knows read this summary, they will say that this is true, but ultimately this is a false attribution. We change the speaker of the statement. And Gandhinagar collector so and so briefed about changes to home minister. So this is again totally in the corrected summary. We have a health minister, but in this case here is brief about now you see here Gandhinagar collector Hitesh Koya has been briefed about the situation by the home minister. Now home minister can never brief to the collector. So this is totally false attributions. So instead of minister, we use district collector. So this is the third part of corrupted summary using false attribution. And sometimes, there is a misrepresentation. So there can, the news article, some media are pro-establishment, some are anti-establishment. So if you see here, this is we generated the summary using the pro-establishment stunt, promptly declaring. So here, the summary will ultimately appreciate the government stance. And this is anti-establishment. Despite of previous cholera outbreak, consistent warning about the condition water pipeline in Kalol, the local failed to prevent another outbreak. So this is the anti-establishment. So, everything is misrepresentation. From the one summary, here is original summary. We use prompt to generate various sort of misinformation that are belonging to different class. So first class is basically fabricated. Second is false attributions. So we change the speaker or the actor. Now here you see the Union Minister Amit Shah has declared. Now there is no point that Union Minister will declare. That's the job of collector. Misrepresentation, and one part is remaining, I guess. I forgot one part is incorrect quantities. I don't have an example. So now this is our prompt actually. So we instructed GPT-4 to generate the summary using this prompt. So we input the original summary. So this original summary is our input, basically original summary. And then, we mention in the prompt that you create for this class summary, you create for this class summary. So this is our adversarial prompt. So this prompt is useful for a fabricated story. So identify important entity event, other information in the article, and fabricate a story with all the information. So this is misinformation of type fabrication using the adversarial prompt. The second part is basically false attribution. So same thing, what we do is identify entities and event and other information in the article. Then, change some information by falsely attributing a statement. So instead of collector, you put Amit Shah. Instead of Amit Shah, you put collector. Change the person. X perform Y or change it to Y. Let's say entity X perform an action. You change it to Y. Something like that. So this is our prompt for the uh, false attribution prompt. And finally, before the returning check, does this summary have only the entity from the original text? So that was a check. So we are not adding any another entity, but with the same entity, we change X and Y. So that's the false attribution prompt. Third one is inaccurate quantities. So here we change the numbers, playing with the numbers. So like 78 million US dollar, we changed to the 21 million resource aid. So this is also one kind of misinformation. 100 billion Indian national rupees changed to 30 billion. So this LLM can also do the corrupt the summary. So in this case, basically our corrupted summary, we change 13 to 13,000. So the person who wants to propagate misinformation, they basically play with the numbers. So these are the 4 types of misinformation using this prompt, adversarial prompt, and this is a prompt for misrepresentation. So basically we instructed that summary should praise or criticize X for Y or whatever the name entity is there. So if you want to generate pro-establishment, praise, anti-establishment, criticize, or bias or favor. So this is a prompt for the misrepresentation. So we also put the Odisha train accident. So at that time, bias toward Russia, exaggerate Manipur violence. So that's the class. Now here, so basic idea is, so what we gave to the participant, we gave participant a corrupted summary. We gave article, and they have to decide whether this is a correct or incorrect, um, correct or incorrect summary. If it is incorrect, then what is the 4 classes of the misinformation? So that was our task actually. So now, interestingly, I mean, people use GPT, use GPT 3.5, but GPT-5 gives very bad results. But for this case, we don't know, but for this case, logistic regression, uh, support vector machine gives better result than GPT 3.5. We are also interested, we are investigating this underperformance, but here the LLM gave, poor result than the classical approaches. So these are some lossy approaches, top participants. And, on result, the F1 score is 0.34. So 4-class classification, the F1 score is 0.34. So it ranges from 0.06 to 0.34. So now what we did, GPT-4 has, you corrupted the summary. Now GPT-4 cannot detect the misinformation. That's the height of this problem. So, here the F1 score is 0.34. The top team on Hindi data set. Now, once again, I'm repeating, the article is in English. We created the summary in English. Then we translated the summary into Indian languages. Now, we ask participant that this is a summary. This is an English article. Now you decide whether this summary is correct or incorrect. That was the idea. And we got the F1 score 0.34, which is quite low compared to the other data set. Similarly, for Gujarati, same thing, 0.33712 to 0.006. So this was the F1 score. Now, final comment. So as I discussed, that traditional machine learning model outperform LLMs for the misinformation detection task. The one reason might be the limited data size of data set. And logistic regression approaches outperform the GPT 3.5. So this was the final observation from this task. What we did is, so this is the miss task 2. So till now I discussed 2 tasks. One is a summarization and third one is misinformation detection from the summary. Now, in 2025, we try to give, try to give a task which prompt recovery. So basically, using prompt, if you go to the step slide, so using this prompt, we generated the misinformation. Okay. Now the idea is, can we retrieve this prompt if given the misinformation is there? Now, can we document is there? Now, can we retrieve the prompt? So this was the task of prompt recovery. Okay. So prompt recovery is basically from LLM generated misinformative text. So prompt aiming the possible input prompt used to generate the misinformation. So our idea is, can we regenerate the prompt which generated the misinformation? So what is the task is, we gave an article summary together with the misinformation containing the title. So there is a summary, there is an article, and we ask participant to predict the prompt that have been used to generate the title from the summary in an open-ended prompt generation setting. So that was a task. Once again, I repeat, there is a article, new article, summary, and title. So, this task was too difficult task because nobody submitted the correct run. So, I mean, still we are working on that part. So this is the prompt recovery is basically, focus on reconstructing the instructional input that drove the transformation from grounded summary to the misleading title. So that was our task. Basically, we did not get any good participation over here. So each instance contain a news summary S and generated misinformation containing title T. Now output is a natural language prompt P such that generated condition SP could plausibly produce P. That was our problem. So we provided the training data STP, so summary, title, and prompt. So basically, they can train the model, and P is a prompt used to produce T from S. So title generation is produced from the sentences, and test data contain S and T. So system must predict a missing prompt P head. That was the task. So, task framing is basically P head is equal to R max. What is the probability of particular prompt P given summary and title? So basically that's the prompt generations. Okay. So these are the 3 tasks we did in a summarization part. I mean, in our lab, we are working on these 3 tasks. Now we will focus on another low resource language task, that is sequence classification task. So here we discuss 3 tasks: sequence generation task, summarization, misinformation generation, and prompt recovery. So this is the 3 sequence generation tasks. Now I will move on to the first task, that is in a sequence classification. That's the hate speech. So Now, when we talk about the hate speech, is hate speech, or there are many variant hate speech, or offensive, abusive, pejorative. So many titles names are there. So, uh, I'm also running one HESOC forum, which is basically work on hate speech, hateful meme. So we prepare the data set, plot the data set, and we get, we benchmark the data set. That's the under the HESOC forum. So this is sequence classification task. So here is a tweet. So from the one, sentence, can we, uh, say that this is a hate speech? Second, now here, this tweet target a group of people like a Hindus. It's a group of people. So that's a potential hate speech without any context. Now, sometime you get this, we see this all data are coming from Twitter actually. So someone died. So here is a context actually. The entire context is there. So here you will see that there is a English, there is a Hindi, everything is there. And there is a dialogue. So there is a social media conversation. So now, can we have a, uh, you know, this is also, how do we formulate this problem? This is very easy. You can say yes or no, but here is a dialogue. So whether this one, or this one, there are three messages, the entire thread conversation. Now, how do we formulate the problem in the context of hate speech? Okay. So, as the opportunity is, how do we transfer knowledge from high resource language to a low resource language, English to the other languages? And challenges, the biggest challenges is the human annotated training data, multilinguality, and code mixed language. Now, sometimes even LLM, if we use LLM as a judge, sometimes they also made the mistakes because our data is basically in a three part. So here is, binary, multi-class, multi-label problem. We can, now comes conversational. So I will focus on a conversational part. Now here we publish a paper in expert system. So that was a conversational hate speech problem. And now sometime, a conversational thread can also support hateful or offensive profane content, which is not apparent from a standalone or single tweet, comment, or reply to the comment. But if we read the entire conversation, then we can also see what is a parent tweet. Now I'm sorry, there will be some abusive word, but that's what we are working. There will be some bad words, um, but you have to bear with me. So now you see here that was a one tweet is there which has some bad word. Now someone is written Amin or Amen. So they are basically supporting the profanity. So in that context, the reply, if you consider this comment as a standalone tweet, this is not a hateful. But now this Amin is supported to the profanity and abusiveness. So these are also a hateful replies. Now this comment does not express hate by themselves, but they are supporting hate expressed in a parent tweet. Okay. So this is also a, this can also be considered as, as per the annotation. If you try to annotate the dialogue, the person who support profanity or hate or the text, it's also considered to be a hateful. So this was a problem we tried to formulate. So what we did is we sampled the Twitter dialogues. We captured the dialogue, and then this is another interesting dialogue. Now, if you see, you totally nailed it. It can't stop laughing. So this is just a normal text, but they are supporting the profanity. So in this case, this is also a code mix. Now, if you see, this is a code mix written in a English. They've used some character to use swear word, and this supporting them. So this is also a in as per our annotation. This is hateful. Now, how do we annotate them? So we created, so this is a famous dialogue from George Bush when 9/11 was happened. They says there is no distinction between those who commit the terrorist attack and those who harbor them. So with this guideline, any tweet that support the profanity or hate are also hateful. So we created our own platform, annotation platform, and we try to, um, we try to annotate them in a conversational dialogue. So this guy he just announced that I'm a COVID positive and recurring. Now there's the guy who just for the first time so did say any positive news. Now if you see, this is in reply, this is abusiveness. Okay. Then this is potential hate because they are not, but this second reply to the main thread, it is completely, okay, or we can say there is nothing abusiveness, but if you consider the parent tweet, this is abusiveness. So it's a like implicit hate, we can say. So now this guy is replying. Now I'm not spelling out the word, but so this is, if you can, so to decide the label of this, you have to refer the entire dialogue. So this is our annotation platform we made for this kind of problem. Okay. Now, even for this tweet on LinkedIn, I received the text. This is not a religious hate speech. This task is good, but data needs to be. So sometimes, the agreement between annotator is very, very poor in this case. So that's what I mean. It's the annotator agreement is around 0.6 to 0.7. So in our, ASOC data set, the agreement in English was around 69%. And the disagreement between annotators, we resolved using the majority voting. So that was our 69%. So it is very, I mean, not good, but it's okay, average level. And for any hate speech data set, the agreement is always around this range because people come with different mindset, different things. So basically what we do is, this is our text, that's the human see, but the PC or AI model see as a vector. This is the vector which is fed into the models. And now I will not go into the detail, but this is our problem. Okay, we gave these dialogues to the participants, and this is our results of okay, the F1 score is around 0.72 points. So still there is a scope for our ASOC task. And this is, the macro F1 score for the standard. Still this multilingual BART, XMLR, Roberta are the top teams approaches in 2021, 2022. Okay. Now we did some interesting work. We tried to create the browser plugins to visualize the head. So here is one example. So we created plugins. So whatever we read from Facebook, that will go inside to our model, and the model decide the labels, whether it is implicit hate or explicit hate or abusiveness. So, if you install our plugins, then it will do some colorful part. So this is abusiveness, there is an implicit height. If there is a green, then so this is we did the height visualization over the Facebook. Now this work was published in expert system. I'm not mentioning, but in 2022. Similarly, we did it for Twitter also. So this is the implicit height again for the Twitter datasets. Now, the biggest problem with this is a model generalization, multimodality, low research, and capturing the context. So these are the challenges. So, with 3-4 years of my experience in this field, we think that we don't have a data set that can be a standard data set. There are 50 plus data set for hate speech in available into the uh, community. Uh, you know, but I don't think so. A single data set can be you can consider as a hate speech data set. So these are some results. If you have a one data set, you train and test, but if you test on another unseen data set, the result goes very, it's 0.81 F1 score reduced from 0.816 to 0.178. So this is cross dataset experiment which performed by Karan and all. So if I say that on my dataset this is 0.81, but if you test on another dataset, due to the bias, you are not getting the proper result. There is substantial decrease from 0.81 to 0.178. Same result with the bird. So this is again one experiment. This is a data set. See, on same data set, it achieve F1 score 0.87, but if you take another data set, the result goes down to 0.598. So the cross data set experiment or the model generalizability is the biggest issue for the, this hate speech research. Now, there are some observations reported by some of the researcher. The dataset with larger percentage of the positive sample tend to be generalized better than with the fewer samples. Type of data and labeling criteria are higher relevance than the model, and but is possible of some generalization which is highly dependent upon the data. So these are some observation of the generalizability, and there are some open questions. So I will skip this part and I will go to the problem of multimodality part. So if you see over here, now, the our Twitter is full of meme. So if you see the meme, I need this one. Okay. So love the way, so here is the image of skunk. Now it smells really bad. So if you see the same text, if I change to rose, then this is very pleasant utterance. But for the love the way you smell today, love the way skunk smell. So here, if we change the background, the meaning or utterance is completely changed. So now from text, we migrated to the meme part. So many real-time, samples are multimodal in nature. So if you see the Twitter, Indian Twitter, I mean with Indian, most of the posts are, with pictures and text. So here is consider the love the way you smell today. So if we just take text, it is completely, fine. Or look how many people loves you. If you only consider the text, this is completely okay. So unimodal and multi model. So unimodal, if you consider text or image, they are totally normal. But if you consider image and text, then this is abusive the way. So unimodally, these sentences are harmless, but combined with them equally harmless image of the skunk or tumbleweed, suddenly they become mean. So similarly, the another example. Look how many people love you. So it is one kind of negative comment on a person. And if you change the background and look how you see the text remain same. The background is changing. So meme are often subtle, and while true underlying meaning may be easy for human to detect, they can be very challenging. So as a human, we can easily see, but can AI model detect the abusiveness or offensiveness? Similarly, this is an example of Gujarati meme. So we are working with Hindi and Gujarati. So you see over here, Jo Bhai. Now this is, I will translate for you in English. Jo Bhai, Tara Nanpanno photo છે. So this is a Gujarati text. So basically in English, it's called, look, brother, this is your childhood photo. Now here is a monkey. So this is one kind of abuse. You are trying to abuse or something like. Similarly, this is also a well. So to fix this kind of problem, uh, we publicly announced the HESOP 2025 meme data set. So this is a data set where we given the training data into 5 languages: Bangla, Bodo, Gujarati, Hindi. And so these are the 4 languages. Total training data was 5. So there are 5,000 plus meme. We also have a test data 3,000 plus. And the task was, can we have a sentiment? Because many times there is a negative sentiment or positive sentiment. Now this is can be also uh, negative sentiment or positive sentiment, abuse or not. So there are different times: sarcasm, non-sarcasm, sarcasm, vulgarity, abuse, and target. So we formulated 5 binary classification tasks on that particular meme image. So similarly, this is the Facebook data set. I took it from Facebook, but we also sample it from Instagram and Facebook and such memes where you will find text and images, feed it into the transformer, and you will can decide what is the category of this particular meme. So this is our data set overview, where we have a 5 classification tasks, and there are various classes like gender, religion, or political. So the approaches are basically, what we do is we can use image and embedded text as input. We are using Gemini 2.5. So one student is doing thesis under this problem. So yeah, you can do the image decomposition, OCR, English translations, and there are some prompt-based approaches, cross-modality encoder, text-only enrich, and uh, using reg. So many approaches are there in one. So one MTech student is doing under project with me. Just and these are the ensemble, and we can do the fusion selections, ensembling, and the threshold calibrations. Right? And these are the results on this is aggregate F1, average macro F1 score. So for zero shot Gemini, we are achieving around 59%. In few shot, sometime it decrease, but in Hindi it remains same. So we are trying to investigate this also. Then we are using some transformer XML Roberta. Then text enrich, hybrid ensemble. So we are getting different F1 score across the different methods, but still it is around in the range of 665. So we reach at the top. But not in the range of 0.9. So okay, 1 minute. So basically, in a Twitter, we need to create a vector while merging all these three conversion and feed it to the uh, AI models or any machine learning or deep learning model. So the text representation of this entire dialogue, either you consider give whole dialogue, or because there can be many comment. Similarly, this is also uh, so if you see the 2nd October, there Nathuram Botse is trending. So in this case, we need to capture the text as well as need the OCR. So now that this all harmful language detection task is converged into the meme kind of text, because picture worth more than 1,000 word. So with this, we are also migrated to the hateful meme, something like that. So to capture the context, you need to, you see here. If you do the annotation, then if person don't know about Nathuram Godse, then there is no point. So, but we give some context to the annotator, and then this is also Mahan Deshbhakt, something like. So this is, we try to annotate the entire context. This case, okay. So it's all about from me. Any question? I'm happy to take questions. So I will take to the first slide where I started. So I cover the three problems, starting from summarization to the hateful meme. I just discuss it very high level, didn't go in the detailed part. And now there is I think that these slides, there is a hateful span. So where we have to, detect the sequence of token, which can be labeled as a hateful span. So we can formulate this problem as a sequence labeling task is also. So that's all from my side. Any question? I'm happy to take all this question. Thank you.
Is any questions from the audience side, participants? Sir, Sandip sir, if what about data set is available on the hate speech, like you told that more than 50 data set is available. So
Yes.
can we convert those data sets, whatever contents are there in Gujarati, Hindi, or Bangla or English? So can we
But
convert into local languages like Odia? Suppose I want to start some work on hate speech, instead of
yes.
collecting data from the Twitter or Facebook. If those
Uh,
data I can convert, means I will take some local students, and he is supporting me to convert those things. So can we test those data, or we can do some work, or we have to collect from the Twitter and Facebook one?
okay. I will come. I will come. There is one paper. We did that experiment in 2023. I will show you this by our paper. So what we did is basically there was a data set in Sinhala.
Okay, Sinhala.
Okay, Sinhala. We work with Sinhala also. So what
Okay.
we did is we use the sphere word in Sinhala and translate into Gujarati.
Okay.
Can you see my screen?
No, sir. Same screen.
1 minute. 1 minute. I will share. 1 minute. I will share my screen, sir. I
Yes,
will do
yes.
the full screen.
Yes, sir.
I don't know what is the. screen.
Share the screen again. Again, you have to choose. Open that particular screen first, then share that particular
But
windows.
I can share the PPT, but I don't know I can share the entire screen here.
And not entire screen. You just first open that particular paper, then
Okay.
share that one and select that particular window.
Okay. Okay, 1 minute.
Share and select the particular. First open the paper, whatever paper you
Okay,
want.
1 minute, 1 minute. I cannot share my entire screen. I don't know whether.
Oh, okay, sir. Otherwise, you can send the paper to me. Okay, I'll check
Okay.
that one. Or you
So,
can tell.
okay. So basically, what Professor, we did one experiment. There were, I mean, since there is a bad word, I mean, the hateful word in Sinhala, we translate into Gujarati, and then using this seed word, we translate. I mean, we sample the Gujarati data set. But what you said, um, that English language data set translate into Gujarati, but there is a translation error. I mean, the translation adds some noise. And sometimes the sentence becomes meaningless.
No, sir, what I'm telling, if we can include some of the student of that particular language, suppose I want to, the Odia student I will take. So he is going to not send them word by word. He's going to convert that English sentence to
Okay.
Odia. In
So
that case,
manually, are you talking me about
yes,
manually?
manual, yeah.
Then that's a good experiment.
Otherwise, Google Translator or any translator will take, that will not give the
Yeah.
meaningful.
Because we tried in 2023, then what happened, that the translation quality was very bad,
Yes, yes,
and
that
the meaning utterance is completely changed. So
yes.
then what we did is we take the word from one language, translate it into the target language, and then using that sphere word. Let's say I want to create the corpus of sphere word in Gujarati, then I have to take reference from one language. So that's how we. And right now, the uh, Twitter has stopped sending the data. So this one is also, a problem. You cannot distribute the data. So
Yes,
what
yes.
we can do is there is existing English or other data set. We can translate into Gujarati, but there is a lot of manual effort.
Okay, sir. Any questions from audience side?
And I would like to invite your student to, I will share the link with Fire. There are a lot of tasks. So if they want to start career in NLP or IR, then they should participate in a small task. Okay. First, they complete the task. Then they identify the research component where we can make the improvement. And then they can publish some good work. They come to the conference, analyze the problem, how they can make better solution. So, this task is, the first step to the research career, basically. So
No,
this is
I
my.
will contact you, sir, because myself is also in that particular NLP line.
And
So definitely, here also adjacent to this KIT University, we have one KIS University is there, which is a tribal university of the first tribal university of the world, where 40,000 tribals are studying from
Oh,
KG to
great.
PG, everything is free. So what
Great.
I want to say, so there around 64 different languages students are available. All are
Okay.
tribals of Odisha only, tribal languages. So along with that one also, we have around more than 1,000 African continent students of
Oh,
different
great.
countries, like you can say Ethiopia, Chad, and then Somalia, like that, Zimbabwe. So they are also interested on NLP, and I have collected the list of the students those who are interested. So we can also use them to prepare the corpus. Then we can work on them. So definitely, I will be in talk with you in details, so
Sure,
that how can we can apply some project, or we can do some prepare some purpose and can work. So I will connect you later, definitely. So anyway, sir, thank you very much.
Thank you.
From the net only, Miss, I saw you, and I have given you the invitation, and thank you. You accept my invitation. So
Okay.
I am
Thank you.
here in KIT for the last 24 years almost. Okay.
24 is a big year.
Yes, 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 yes.
Actually, I was Italy and I just, came back to India for 8 months.
Yeah, yes.
Okay. And please do visit Gandhinagar whenever you come. Okay. We'll be
Okay,
happy to host you.
definitely. I will be in touch with you and we'll discuss more.
Okay.
Thank you very much, sir. Thank you. No.